Alright, so solving absolute value inequalities by the test point method. So in our first example, we have the absolute value of w plus 2 is greater than 6. To use the test point method, the first thing we do is ignore the inequality and set up the two equations. So just pretend that there's an equal sign there. So we would have w plus 2 equals 6, or w plus 2 equals negative 6. Now solve these two equations. So in the first equation we have to subtract 2 from both sides. That's going to give us w equals 4. In the second equation we would subtract 2 from each side, and we would get w equals negative 8. These are what are called boundary points. So what we want to do now is draw our graph. For now I'll just draw a straight line and graph the point 4 and graph the point, whoops, I suppose I should go down now. Let's make this negative 8 so that we can make this 4. Alright, now this is called the test point method because, as you can see, our 2 points divide the graph into 3 regions. 1, 2, 3. What we want to do is choose a point in that region. So choose something less than negative 8. So I'll choose maybe negative 10. Now we want to choose something between 4. So I'll just choose 0. And then choose something greater than 4. So I'll just choose 10. I try to choose values that are fairly easy to work with. What we're going to do now is test each of these points. Since the inequality is strict, it says the absolute value is strictly greater than 6. We know that our points, negative 8 and 4, won't be included in the solution set. So all we have to do is test these 3 points. And we go back to our original inequality to do that. So let's test w equals negative 10. Well, that would give us the absolute value of w, which is negative 10, plus 2 is greater than 6. So that gives us the absolute value of negative 10 plus 2 is negative 8 is greater than 6. And the absolute value of negative 8 is 8. So we get 8 is greater than 6, which is true. Since that was true, we know that that whole first region is included. But remember that negative 8 is not included, so we have to use a parenthesis. So we put our parenthesis down, and that whole first region is included in our solution set. Next we want to test our second point, 0. So w equals 0. So we plug it in and we get the absolute value of w, which is 0, plus 2 is greater than 6. So that gives us the absolute value of 0 plus 2 is 2 is greater than 6. And the absolute value of 2 is 2. So we get 2 is greater than 6, which is false. That means that this whole second region is not included in our solution set. So the last test point we have is w equals 10. So we plug it in. We've got the absolute value of w, which is 10, plus 2 is greater than 6. 10 plus 2 is 12, so we get the absolute value of 12 is greater than 6, which is 12 is greater than 6. And 12 is greater than 6, so that's true. So remember, this is a strict inequality, so 4 is not included. But this whole region to the right of 4 is included. Now, we want to include this whole thing. We want to exclude the middle, and then include this whole thing. So our first part of our answer is from negative 8 all the way down to negative infinity. But we also want this stuff that's greater than 4. So we write union, because we want or, union, from 4 all the way up to positive infinity. And that is our final answer. In example 2, and remember with these absolute values you really want to look at the problem first. When we look at this problem, it says the absolute value, and we know that that absolute value will always be positive. So it says the absolute value is greater than or equal to 0. Well, a positive number is always greater than or equal to 0. An absolute value can't be any less than 0. So this is all real numbers. And if we want to say all real numbers with interval notation, what we mean is any number from negative infinity all the way up to positive infinity. We could use the test point method on this one, but what we would find is that every region had solutions, and so our entire graph would be filled in. But it's a lot easier just to make sure that you check your absolute value inequality first. So once again, an absolute value is always positive, and a positive number is always greater than or equal to 0.